Let's try some dot structures for some molecules. These are going to get a little bit more complicated as we go down our list here. We're going to start with CH4. So the first step that we want to do is to count up our valence electrons. So for carbon, we have 4. For hydrogen, we have 1, and there's 4 of them. So that gives us 8 valence electrons. And so we're going to put the first non-hydrogen atom in the middle. That's going to be carbon. We're going to attach all of the atoms to it with a single bond. There we go. And we used up 8 electrons to do that because each of those bonds counts as 2 electrons. And we are out of electrons. And so now we want to see if all of the octets are met, or in the case of hydrogen, a duet with two electrons. Carbon has 4 bonds to it, so that counts as 8 electrons. And each hydrogen has a bond to it, and that counts as 2 electrons. So all of our octets are in fact met. Let's take a look at water here. So for water, we have a hydrogen. So hydrogen has 1 valence electron. There's 2 of them. Plus oxygen, which has 6 valence electrons. So it also gives me 8 valence electrons. So we're going to come over here. Let's put our oxygen right here. And attach my hydrogens with single bonds. And so that used up 4 electrons. I've got 4 left. Normally we would put those 4 electrons to fill in octets of the outer atoms, but since we have hydrogens, we don't fill in octets of hydrogens, and so we put these last 4 electrons as pairs on that oxygen atom, and now we're out of electrons. We get to 0, and so now we can check for octets. We have oxygen that has 2 bonding pairs and 2 lone pairs, so that's 8 electrons. And each hydrogen has a bonded pair attached to it, so that counts as its 2, and all of those atoms are happy. Let's try a little bit more difficult one, COBr2. We did this one in class. So we have carbon with 4. We have oxygen with 6. Bromine has 7, and there's 2 of them. So this gives us a total of 24 electrons. So we're going to put the carbon in the middle because it's listed first. Going to attach the bromine to it, oxygen there, bromine there. That used 3 bonds or 6 electrons. So I've got 18 electrons left. We're going to fill in our octets of our outer atoms, so they each need to get 6 or 3 lone pairs. And that used up all 18 electrons, and I have none left. And so what we're going to do here, we check carbon, and carbon does not have 8 electrons. It only has 6. And so we're going to bring a pair from either of the bromines or from the carbon to get to form a multiple bond between carbon and that atom. And what we're going to look at a little bit later is that we bring in a pair from the oxygen here to form a double bond with the carbon. And so now when we check our octets, our bromine has 3 lone pairs and a bonding pair for 8. This bromine has 3 lone pairs and a bonding pair for 8. The oxygen here has 2 lone pairs and a double bond for 8. And the carbon has 4 bonding pairs. So that has 8. Check this last one, ClF2-. So when we do the dot structure for this, we've got to keep in mind that we've got an extra electron there, so we have to include that in our electron count. So chlorine here has 7 valence electrons. Fluorine also has 7 valence electrons. Sorry about that. And there's 2 of them. And I've got to add the 1 because of this minus right here. So that goes because of there. When we add all of those up, we get 22 valence electrons. So we're going to put the chlorine in the middle because it's listed first. We're going to attach fluorine there, fluorine there. That used up 4 electrons, so I have 18 left now. Fill in the octets of the fluorines. That required 12 electrons. That leaves me with 6. That means I need to put 6 more electrons around that chlorine to use them all up. And what we see is that we have fluorine with 8. This fluorine has 8. And the chlorine here actually has 10. It's got 3 lone pairs and 2 bonding pairs around it. And so this is what we call an expanded octet. And since the chlorine happens after phosphorus in the periodic table, that is fine for that to happen.